Hi everyone, I am M. Lokesh Kumar Reddy. I am from CSC Department C section. My topic is molecular orbital theory. First of all, introduction to molecular orbital theory. Molecular orbital MO theory explains how atoms combine to form molecules by sharing electrons. It describes the formation of molecular orbitals through the combination of atomic orbitals. This theory provides insights into the bonding, anti-bonding orbitals, and overall stability of molecules. Atomic orbitals and their combination. Atomic orbitals are regions where electrons are most likely to be found around an atom. When atoms approach each other, their atomic orbitals overlap to form molecular orbitals. The type and symmetry of atomic orbitals determine how they combine to form bonding or anti-bonding molecular orbitals. Next, formation of molecular orbitals. Molecular orbitals are formed by the linear combination of atomic orbitals. When atomic orbitals combine constructively, they form bonding molecular orbitals. Destructive combination results in anti-bonding molecular orbitals which are higher in energy. Bonding and anti-bonding orbitals. First, bonding. Bonding molecular orbitals stabilize the molecule by lowering the overall energy. Anti-bonding. Anti-bonding molecular orbitals destabilize the molecule due to increased energy. Anti-bonding molecular orbitals destabilize the molecule due to increased energy. The relative energies of these orbitals influence the bond order and stability of the molecule. Next, molecular orbital diagram of diatomic molecule. The molecular orbital diagram displays the energy levels of bonding and anti-bonding molecular orbitals. For diatomic molecules, atomic orbitals combined based on their symmetry, symmetry and energy. The filling of these orbitals follows the Pauli exclusion principle and Hund's rule. Next, bond order and molecular stability. Bond order is calculated as alpha the difference between the number of electrons in bonding and anti-bonding orbitals. A higher bond and order indicates a stronger and more stable bond. Molecules like O2 have a Molecules like O2 have a bond order of 2 indicating a double bond. Paramagnetism and diamagnetism. Paramagnetism molecules with unpaired electrons in their molecular orbit are paramagnetic. Diamagnetic. Diamagnetic molecules with all electrons paired are diamagnetic. O2 is paramagnetic because it has unpaired electrons in antibonding orbitals. Applications of molecular orbital theory. Molecular orbital theory helps explain the magnetic properties of molecules. It contributes to understanding reactivity and stability in chemical reactions. The theory is essential in the decision of new materials, including conductors and semiconductors. Next, limitations of molecular orbital theory. Molecular orbital theory can be complex for larger polyatomic molecule. It often requires computational methods for accurate predictions. It often requires conventional methods or accurate predictions. The theory sometimes oversimplifies electron interaction in multi-electron system. Molecular orbital theory can be complex for larger polyatomic molecules. The theory sometimes oversimplifies electron interactions in multi-electrons. Thank you.